Hey everyone, here's a video response to the question that a couple of people have answered or have asked that they want an answer for, and it was something I put on YouTube recently. Currently only 67% of people have got it correct, and I'm just going to go through the solution here. So we've got obviously an integration problem here. A level, you've only got two real types of integration, that's by parts and by substitution. Typically with substitution, you will see a derivative of one of the functions in there. I'm pretty sure that the derivative of this is not 2x. So I'm just probably favoring on the side of by parts. And by parts kind of works when you've got a multiplication of two things. I wonder why. Well, without going into too much detail, it comes from the product rule. So you can derive the integration by parts from product rule, and that's for a different video again. So what I'm about to do is based on a lot of those methodologies, seeing the patterns and then just going for just the solution really, not the explanation. So we first of all want to define both of these separately. So we're going to go for u is equal to 2x. And in this methodology, there are certain elements that we need for the formula that work. What we're missing here is v and v dashed. Now, the way that it works is that the format that we are supposing here is made up of a function multiplied by a derivative of a different function. And so we have to define one of them as a derivative, and that's going to be e to the x here because it's actually quite easy to integrate. And when we are using it by parts, it's much better. I talk about this in a different video, but it's much better to have the one that we differentiate to be something which I call reducible. So when I differentiate this, and we'll just get ahead and do that now. So I set up my table. So when I differentiate this, I got u dashed, and that's going to become 2. What I've got rid of is a variable, and that's really important if we're going to move on to the next stage in a nice, easy way. Second, we've got v dash. So actually what we're going to do here is we're going to go back to v. So thankfully, when we integrate or differentiate e, we just get e to the x. So now we have all of these elements, we can put it into the formula. And to remind us of that formula, I'll put it just off to the side here. The formula itself, as I said, is derived, and it can be seen in a different video. But if you have something that's in this format, which we just discussed we do, then the solution is going to be uv subtract the integral of u dashed v. Really cool to have a quick look at how this structure works. Okay, so you can remember the uv part pretty cool, but the hardest part is which way around do these dashes go. It's quite nice that it's the opposite of what happened at the start. Okay, so this is the formula. So we're just putting it into here. Essentially, that means that we've got u times v, which is this diagonal here. So I don't actually use this formula at all. 2x e to the x. And then we've got these two down the bottom that will go here. So that's u dashed v. So it creates this sort of a shape here, like an angle. So subtract the integral of 2 e to the x dx. This is the integral, but the problem is there's a little bit to figure out because this isn't essentially an answer. You need to integrate this. My favorite way of dealing with this is to take out constants. And you can do that. As long as it's a numerical constant, you can take it out. And then we integrate the e to the x, which we know is just e to the x. So we have 2x e to the x subtract 2 e to the x, and we will plus c. And what we see from these first two terms, if we go down a wee bit, is the 2 in both and the e to the x that's in both. And, well, essentially, we can take that out. So I'm going to write it like this first. We've got x left and a 1 plus c. And you'll see that my answer, maybe it was a little bit just to make sure that it looks okay with the way that I have to write it online. But I left the 2 at the front. Then I had the x minus 1. And then I had the e to the x plus c. And maybe that's another element another layer to the puzzle that you have to know how to write in different formats. Because sometimes, they'll say prove that it equals this. And that's essentially how we get there. So if you want more practice on this, rather, I do have a YouTube video on how to do integration by parts. Go check it out in the calculus playlist.